Hello, in this video we are going to look at functions given as graphs. And to look at the graphs, we're going to look at a whole list of terms. We're going to go through these one at a time, giving you a picture of each one and a very brief description of each one. So our first term is increasing, and a graph that is increasing is a graph that is uphill, and that is a very colloquial description. What we would see in this graph is that as the x values get larger, so they would go along this axis, moving from 1 to 2 to 3, etc. So as x values go up in value, will get larger, y values, or in function notation, f of x values, also go up in value. So both of these are increasing. This particular graph, they're both increasing at a constant rate. Our second term is decreasing. And as you can guess, this is a graph that in colloquial terms is going downhill. And that is as you move left to right. So in a little bit more precise algebra terms, here we see that as the x value increases, so my x is going up in value. So from on the graph here, 1, 2, 3, as I move left to right, or even if I would start in the negative, as x increases, my y value or my f of x value actually decreases. So here at 0, my f of x or y value is 5, but by the time I get to 1, it is significantly lower than 5, still positive, but lower, and so it is going down. Our third term is constant, and a graph that is constant is horizontal, and that means that it is not changing in value. So you can see as I move along the x-axis, 1, 2, 3, so as my x value goes up in value, my y value, which can be also called my f of x value, is indeed constant. It's always the same. So I see that this line is horizontal, a constant function. Our fourth term by now is concave up. And when I mimic concave up, I need to have the palm of my hand up. It creates a cup shape. Now, it doesn't have to be a full cup. You could see this one would not hold any liquid. But as I look at this graph, it is indeed increasing, to use the previous vocab word. The values of y and x both are going up as I move left to right, but it's not increasing at a constant rate, making it curved. And whenever we have a curve, we will need to describe its concavity. And so this one is concave up, meaning that it creates a cup shape, or if I try to imitate the shape of the graph using my hand, the palm of my hand would be facing up, and so that is concave up. If it is shaped the opposite direction, it is called concave down. Again, this is used to describe curves. And when I would go to imitate this with my hand, I would imitate this with my palm down. And whenever that happens, I have this concave down idea, and it's really the opposite of concave up. So again, we have a graph that is increasing the entire time. As the x values get bigger, so do the y values, but it's increasing quickly at the beginning, and then the rate of change slows, making the curvature, and the curvature is concave down. Our next term is point of inflection. And it's struggling. There we go. Point of inflection is denoted right in the center of this graph And this is where the concavity changes. Our next term will describe where the direction changes. If this one is not dealing with the direction of the graph. So you can see where the point of inflection is, the graph is increasing both before and after the point of inflection. But the concavity switches there. So you can see denoted on the x-axis, it is concave up for the first half of the graph. We have a point of inflection, and then the graph switches to concave down. So our next term is that term for when we have a change in direction. And the first one we're dealing with is minimum. So on this graph, there's a lot more than just minimum, but there are two types of minimums to point out to you here. They are denoted in these two boxes. So a minimum is equal to a change in direction. And so this graph shows you places where the graph is decreasing with red arrows. And so I can see the graph starting on the left-hand side is decreasing, and it hits this low point, and then it changes direction and goes up again. So a minimum is a low point. Now, on this graph, there are two different kinds of low points. The first one is relative. And so relative means it's a low point for a section of the graph, but not lowest ever. And then the second time we change direction up here, we have a maximum. We'll define that on our next slide. And then our graph continues, and we get down to the very bottom. We get an absolute minimum, which is the lowest ever on this graph. So the lowest output for this function ever is right here at this red point. And so when we have minimums and true with maximums as well, we can talk about, are they relative, meaning they're a low point in their area compared to the others, or an absolute minimum, lowest ever. So let's talk about those maximums as well. So in this graph, we have both relative minimum and relative maximum. So maximum, again, is a change in direction. And it is a high point. So on this graph, I cut off the arrows here when I took the image of it, but it would continue down, going down forever to negative infinity. And it would continue up, going up forever to positive infinity. And so can I tell what the actual maximum highest point ever is? No, because it goes on forever. And can I tell what the absolute smallest point of this function is? No, it goes down forever. But here in the middle of the graph, we have two changes in direction. So where we have a high point right here, that is considered a relative because it's not highest ever, but so relative, and maximum because it is a high point. And then similarly, over here, we have a relative minimum. Relative because it's not the lowest ever, minimum because it is a low point. So maximum and minimum are both changes in direction. Maximum is high point, minimum is low point. Relative is when it's not the highest or lowest ever. Absolute is when it is the highest or lowest point ever. So next we're going to do something that's very abstract, and that is to try to draw a graph based on the words that we're using. So putting our vocab into action. So our first one that we're going to attempt to draw is always increasing, but at a decreasing rate. So always increasing means that it is uphill. That's the colloquial word that we used. Decreasing rate. So rate of change refers to the slope, which is the steepness of the line. And so if the slope is decreasing, this must be getting flatter. So as I try to sketch out what does that look like, I'll draw my axis. I need to go uphill, I can never come down, but I need to get flatter. So I'm going to start really steep, and I'm going to start flattening. I'm never going to get constant or decreasing, but starting to flatten. And so this is a shape that fits the description, and we'll notice that what we drew is concave down. So what we have here is a verbal description of something that ends up concave down. Let's try another one. So this one is also to be always increasing. So hopefully you're thinking as I'm talking, that means that it has to be going uphill, left to right. It says the first half is concave up. So if I imitate that with my palm, that would have to be palm facing up. So on my lap, my hand is turning so that my palm is up, and I'm looking at the curvature of my fingers naturally, and I see that concave up shape. And we also use the word cup for that. And then the second half of the graph is to be concave down. And so this would be palm down. And we noted that what we just drew is, for the first example, was concave down. So we're going to use that shape again. But we have to start with the first half being concave up, or creating a cup shape. So I'm going to start, I don't want to be flat, I want to be always increasing. So I'm going to go uphill very little bit, and then more and more and more, and then I'm going to start to flatten out again. And so this is my graph. So this section here is concave up, because the curvature is that palm up cup shape. This section over here is concave down. If I try to imitate that section with my hand, it's palm down. And so what we did is, in the middle of this, we drew one of our other vocab words. And the one that we drew is right here where the concavity switches. We drew a point of inflection. All right, one more of these. So for this one, we're to draw a graph that is decreasing. And so I'm thinking of, what does that mean? That means downhill. But it is to be concave up, so it is to be a cup shape. I didn't see it exactly like that. So I'm thinking through downhill. I'm going to start high up on my graph and go down, but I need to get a cup shape. So I'm going to start by going down very quickly, and then I'm going to start to slow. Don't want to go exactly horizontal, because that would be constant. So always decreasing, but starts by dropping off quickly and then slows down. And so this gives us a concave up shape, or a cup shape from the different directions. So that's where we're going to end this video. Hopefully that helps you with your vocabulary.